Hi, good morning, good afternoon, good evening. My name is Sumit Sarkar, Senior Director of Product Marketing at Immuta. Really excited to be here to chat and present on examining the current state of data ops and data engineering. I've been working in the data access infrastructure field for over 10 years, enabling data engineers, data scientists, business analysts, and app developers to use data and navigate some of this disruption from new technologies. Maybe it's new database types, new volumes and velocities of data, cloud, et cetera. And I have some experience as a practitioner and architected a data lake at a publicly traded tech company. So I'm really excited to share a mix of some of my background in data and some of the research we've done at Immuta here. So let me share my screen. Okay, so as mentioned, the topic is examining the current state of data ops and data engineering. And what we'll talk about today are, we'll talk about what is data ops and what is it not. And we'll talk about what are the emerging data trends for data ops teams. Then we'll look at some of the research we did and talk about some of the most challenging aspects of managing a cloud data ecosystem. And then what should data ops teams automate in terms of, based on those challenges, to automate access controls and safely deliver data faster. We'll wrap with the Q&A. You can kind of guess from the agenda where the research it did land on a lot of challenges around sensitive data management in the cloud. And so we'll start with the high-level definitions. What is data ops? And I like to also answer, what is it not? And so starting with data ops, the definition from Gartner, this is back in 2019, is data ops is a collaborative data management practice focused on improving the communication, integration, and automation of data flows between data engineers and data consumers across an organization. And I think most people are pretty familiar with DevOps. And my DevOps teams I've worked with always tell me there's no such thing as a DevOps team. But DevOps is really the combination of software development and IT operations. And it's really a cultural philosophies, a mix of philosophies, practices, and tools that really enable an organization to deliver software products and faster than using traditional software development methods. And when we look at DevOps, it's being optimized for software products, and DataOps is emerging as called a parallel function or discipline optimized for building data products, and where the product is the data itself. And ultimately, is that data usable for your consumers? And what data ops is not, it's my attempt at humor, but it's not necessarily a data integration tool, and it doesn't, just having data integration tools doesn't mean you're doing everything in the data ops practice. Anything using Apache Airflow, a lot of organizations may use orchestration tools and just think that I've got all the data ops stuff covered and all my users are happy and humming along with their data. And then another type of underpaid engineer. But yes, at the end of the day, just simply put, it's using more automated and agile approaches, thinking people, process, tools to data management. And we'll touch on some of these in the research and the flow of how to manage some of these challenges that are raised. Okay, so what are the emerging data trends for data ops teams? So we ran, we're really trying to understand the different cloud services and platforms that organizations are adopting in the cloud, but there wasn't very much research out there. And so we ran our first state of data engineering and operations survey to really answer some of the most basic questions and get a baseline on the state of what data teams, what they look like, and look at that by different dimensions. And some interesting conclusions include this, these trends, like look at the migration and expansion in cloud data analytics capabilities. And I think it's about maybe 5 or maybe a little bit more years behind the operational or production side of the business, where business applications are now everything's SaaS, you may have like Salesforce or Workday and Oracle. And we're in the middle of this for data right now. And moving on the trends and some of the answers from, there's about 140 respondents. There are a lot of folks more on the engineering and operations side, like architects, data engineers. We'll call that the supply side of data. We're primarily responding here. And we see this trend where moving to cloud data platforms, 75% are going to be entirely or primarily cloud-based in the next 24 months. And then over half of the teams are planning to adopt 2 or more cloud data platforms. And when we talk about cloud data platforms, these are things like there's a variety of types of services and platforms. And so you think about warehouses like Snowflake or Redshift, or maybe data science platforms like Databricks or Spark, and even ad hoc query engines. Like I think Starburst is the commercial version of Trino or Athena from Amazon. So these are all data platforms and services that represent that 52% number. And I think it's consistent with the narrative from different platform vendors that talk about lakehouse architectures, thinking about supporting diverse workloads for data science, more on the lake side, and BI maybe on the house side. And to me, these results are moving cloud data platforms in 24 months. And this was run back in October, so let's say a lot less than 24 months now. It's pretty fast. We think about maybe how long it takes to get a new warehouse live. And so, this is definitely a trend that I think that a lot of folks on this conference are also seeing. And I think that it's also a sign of not simply moving to the cloud to just save on on-premise licenses. Rather, it represents that organizations are really expanding business capabilities and using best-of-breed services for different use cases. And so, end of the day, we're really seeing an acceleration of both the number and types of cloud workloads. And the second trend is around sensitive and regulated data use. And in looking at sensitive data, it's not really limited to just highly classified data like from the government or intelligence community or health information, but it's really any data from the survey that was for which you wanted to limit access to across an organization, like maybe by business line or geography, where it's sensitive to the organization. And looking at the results, roughly 3/4 collect such data and have plans to use it. And almost all data teams are subject to at least one data rule, whether internal or external or regulation. Later on, I have a slide on what some of those look like from some of the detailed responses. But at the end of the day, the net trend here is that there's more sensitive data is being collected with overwhelming plans to use it. And so that's, you can start to see that's, we're building on some of these more types of workloads and platforms, more types of sensitive data. And then also we looked at some data where data engineers are outnumbered in this calculation in roughly 30-1 by data consumers. And so what this means is on the supply side, we'll call them supply side teams on the left, the operations engineering teams. They're responsible for providing these analytics ready data to those people on the right, the demand side. And they're going to ultimately use that data, analyze it, build analytics products and deliver on the business capabilities. And just looking at this, we did some back of napkin analysis on LinkedIn roles and titles. And that's where we got this ratio of somewhat 30-1. There wasn't a great data point out there. So we started looking at some of this data in professional social sites. And when I talk to the data teams or listen to others conferences and sessions, you hear about the bottlenecks where either the engineering and operations teams, they have to deliver data products to these large numbers of hungry consumers, these little cartoons on the right. or even a small number in the sensitive data environments that are increasing from our survey data. For example, there's a session from CVS Health, and it was in the Q&A, and they were sharing that they needed a ratio of 5 data engineers to 2 to 3 data scientists to get their project started because they're managing some very sensitive data pipelines. And the net here is that the supply side data teams, which were the majority of our respondents, are really outnumbered. And so we'll continue to look at some of this research and dig into this some more. But it certainly is one of the areas where the approaches of DataOps are absolutely required to revisit how cloud data products are delivered. Okay, and so then if we look at some of the more challenging aspects of managing cloud data ecosystem, and again, we define that as being the collection of platforms and services you're using for your data analytics. And the results from the challenges from the same survey, the 140 folks, we looked at the different levels of challenges around data management. And you can see from left to right, which ones were ranked from least to most challenging. They're not necessarily in order of a data pipeline steps, but you can kind of see where the areas are. And again, we're seeing, to recap, we're seeing that acceleration of both number and types of cloud workloads. We're seeing more sensitive data being collected with that overwhelming plan to use it. And then again, the data teams on the supply side are really outnumbered. So what could go wrong, I guess. But these results is not that surprising given that this state and the data engineering and operations challenges are really shifting towards management of sensitive data. If you look at the top 3, like masking or anonymizing data, monitoring and auditing, and classifying, cataloging are the top 3 areas. And on the flip side, you look at the least challenging, things like extracting and loading data in the cloud is more streamlined. It's cloud storage, data lakes. A lot of that work is being shifted to the transform and modeling step with some emerging patterns to transform data like DBT. And so yeah, that's it. This is the current state, right? So we'll dig into some of this, but when we look at like this moving towards sensitive data, the challenges are really multiplying with more cloud platforms, as we saw in the first trend. But when we look at some of these more granular dimensions, the impact of adding a new platform, a cloud platform, or more rules or sensitive data, really seeing it multiplies that risk, cost, and maintenance for managing sensitive information. And so the dimensions, data platforms, for example, just say you have 2, maybe they're increasing as a data point. Maybe I have Amazon Redshift and Athena, and maybe I have Databricks, and those are a couple platforms. And then we look at moving clockwise from the top, data use roles. Things like there's contracts and data use agreements with third parties and any kind of other rules you're subject to. Now we're seeing more of these being implemented as companies use more data and more for more sources. And then in terms of geographies, especially for internal analytics teams, how each country is going to have different rules for how data is used, and there's different maybe segmented by the business needs or other data protection laws in the region. And then going down to the bottom, just tables, how many a lot of data lakes can have hundreds to thousands of objects that map to tables, and so how many of those to have sensitive data. And then looking at the regulatory climate, it's a big factor in terms of regulatory concerns, security concerns, maybe data sovereignty concerns in the cloud. And then up to business lines, this is very common to, you're building a centralized lake or platform, and how do you segment that data? Policies for different lines of business and isolate them as their own tenant, right? I know there's a lot of talk about data mesh as a architecture pattern to decentralize and some of these things by data products and business lines. So these are a variety, and just making a back of napkin calculation here, you get like 50,000 policies pretty quickly. And if you're starting with the cloud, you may have fewer, but as you mature, it quickly grows as that research is pointing to. All right, if I were to just up level it, I'd like to summarize with just 3 things from the research before we dig into some approaches. But the 3 hurdles around these trends: more cloud data platforms and more sensitive data. The net impact of that is it really is going to limit the reason you're adopting cloud to deliver more capabilities to the business. That you look at multiplied role explosion is certainly a hurdle. Roles are becoming harder to manage across the diverse workloads in the cloud, and like hundreds of users. And we talked about those 50,000 policies. It can require like thousands of roles and tens of thousands of policies, creating a bottleneck for data access. And second pillar on it's hard to classify and manage sensitive data across these heterogeneous platforms. And then third, the disparate data protection. These implementing data protection policies can vary for each cloud platform and service. And so again, that just introduces those challenges that were reflected in the survey results. Okay, so where should DataOps teams automate access to? And so based on that research, we started to look into why data is hard to manage in the cloud. And as part of that, I'm going to uncover or share some of the findings through a series of illustrations in a cloud architecture, and then look at the different points where you can automate these controls and manage some of those top challenges with sensitive data. And really the reason it's challenging for data engineering and operations teams from some of the quantitative research we did following this work is there's just so many layers to manage sensitive data and sensitive information in these modern cloud data ecosystems, and it's really requiring automation. Right now is one of the approaches with DataOps to feed data between the supply and consumption side using automation. And this is a diagram from the A16Z for modern data architectures. I really like it represents a lot of the architectures I've heard about. And it also shows the different layers where these controls to manage data are implemented. Looking from the left, the raw sources to the second layer, maybe hard to read for you guys, but the ingest and transform to storage and query and processing out to the output layer where the consumption side is looking, those analysts and scientists on the right. And so that's really the flow in this architecture. And looking at each layer, we'll dig into each, but getting data safely from the left, supply side to the right, the consumption or demand side, involves a lot of manual steps and for most organizations, and really limits the delivery of data to these hungry data scientists and analysts. And then it's ultimately a bottleneck, and the business stakeholders, I guess, are waiting less patiently, even further to the right, not pictured on this slide. So these are certainly challenges. And if any of these layers where you have the opportunity to set controls are left open, either by design, maybe you have a group that requested direct access to your object store, or maybe by accident, maybe you deployed some code changes that opened up some gap in the protection, it can result in a leak, and a lot of bad scenarios that everybody, I think practitioners are well aware of those. And it kind of reminds me of like very high pressure environments. And you talk to a data engineer, they go to bed thinking, did I filter those hundreds of thousands of subscribers in this region in my code? And architects and other leaders are having that same concern across multiple platforms and across this whole surface area in the ecosystem. And that's really where organizations look to adopt more automation. And so we'll look at each layer and look at the trade-offs for implementing controls. All right, so if we look at ingestion and transformation layer, we're moving left to right in that image. And so we look at these, we're going to score these just for consistency, where each layer and the assumptions are you need fine-grained access control to sensitive information. And you're looking at one, safety, what's the risk for unauthorized access, or really zero data leak potential. 2, utility, is that data accessible for creating business value? And 3, on scalability, can protecting data at this layer support increasing numbers of users and policies and rules. And at this layer, protecting data on ingest was a common pattern in on-premise architectures using like ETL tools, so you can mask the data prior to loading into a database or warehouse or even into a Hadoop platform. But this data was protected at rest and for subsequent downstream use. And so from a safety perspective, high is good. It's protected at rest, so there's not much that can go wrong. But then I guess from a utility perspective, that raw data is obfuscated, generally inaccessible to users, and scalability, these policies are often require duplicating data for different users and segmenting that data for rows, like by business line geography, is done at a different level in the stack. And so, we talked about masking, anonymizing data was a top challenge shared in this research. And it may be safe for specific scenarios, like maybe PCI compliant, but really limits the capabilities around sensitive data use in the cloud. I know Gartner has a market guide for data masking. It was published in December 2020. Talks about this approach. They call it static data masking. And it's reached this plateau back in 2017, according to Gartner work. And after all, the easiest way to protect data is to not make it available in the first place. So, it's not a great place to centralize approach, but there are certainly use cases at this layer. And then if we look at the next layer, going to the right, the object store layer, and protecting data here sounds like the obvious choice. And Amazon, like S3, has buckets and user policies, and you can grant access to coarse-grained resources. Similarly for Azure and GCP, their data lakes and object stores, but you can't actively filter or mask rows and columns that are sensitive and structured data unless you have some compute resources. And so the storage layers like S3 and the ones from the big clouds, by design, don't provide fine-grained access control or really dynamic data protection functions by design. And so when you look at safety, these coarse-grained access introduces risk for data leaks because you can't really filter data or obfuscate subsets of that data. And from a utility perspective, your access is all or nothing. So if you're not authorized to use it, you don't really get access to any of the data. So it increases the number of unauthorized users who can't do much with it. And then scalability, coarse-grained access doesn't scale as much for policies. For example, if you're segmenting rows by your business lines, for example, or maybe by region, you really have to duplicate that object and create subsets for each policy and user combination. And so that's a challenge for most teams. And a lot of organizations will completely remove direct access to an object store because our security and privacy team requires it for sensitive information. And for unstructured objects, where fine-grained access is not required, these dimensions are less applicable. But the net is, this is not the right place for fine-grained access controls on sensitive data in your cloud platforms. All right, moving further to the right, looking at the query and processing layer, the cloud data platforms and services, we're talking about things like maybe like the Databricks and Snowflake, which are more cross-cloud, or maybe like Athena or Redshift that are more cloud specific to like Amazon as an example. They represent the layer where data processing or compute resources are required to filter and mask some of the data to enforce those access control policies. And so from continuing down the scoring of this layer for both safety and utility, it can vary since native controls can work well for basic policies, but each platform has a wide range that's not necessarily consistent across with enforcement. So you could have as an example, you could have an ad hoc query engine, maybe like Athena, and provide controls to segment data, but maybe your cloud warehouse doesn't have that support. So from a scalability perspective, it's low to medium. This may work on a single cloud platform with simple rules. Actually, let's start with going back to safety. Safety and utility or medium low. And scalability is like looking at the single cloud data platform and simple rules. That, again, that can work okay, but as you increase the number of platforms or rules increase, some of those native controls and in the platforms and services are going to differ from each platform. So it gives you this heterogeneous environment, and managing them with the platform specific controls makes it really hard to maintain and can increase like your exposure to leaks if you're managing these policy updates in many places. Again, it's that you've got these different points of enforcement, even in different layers here. So you have, within this layer, you have even different points of enforcement. And so this is the right layer to enforce policies on top of storage using compute resources, but it really needs to be centralized. So the net takeaways, I think it's getting closer to where the place to automate a lot of these controls and management of sensitive data, but it's not suitable for this expanding cloud ecosystems we talked about that are growing in the earlier survey. And then on the last layer here, the analytical tools or the output layer, these are really these tools, like thinking like big clouds have tools like Power BI or on Azure or Amazon QuickSight, or some of the cloud agnostic tools like Tableau or Looker. These analytical tools are increasing their ability to store, usually as extracts and process data. So you get even more potential protection endpoints at this layer as well. And there's they have different approaches often. So for example, I use Tableau a lot, and I believe I also use Looker, but I believe you can implement row level segmenting in Tableau. You can create user filters and map users to values manually, or create some more dynamic filters and calculate fields to do something with some automation. But go back to the scoring, the dimensions, let's say safety, data can get leaked anytime someone accesses outside your logic here at the BI tool levels. And so that represents a risk, and it can create a challenge with shadow IT, which happens a lot, right? Where you're managing a lot of these rules by lines of business and it's not consistent. Then if you go down to utility, it's more low to medium, but end users can use the data they're authorized to see, but analytical tools lack some of the more advanced techniques to mask and anonymize data. And so there's some inconsistency in what kinds of rules can be applied across these technologies. Because they're at the end of the day not designed to be data compute technologies to process and share data. They have some capabilities, but it's low to medium in utility on making it usable. And on scalability, again, it doesn't scale when you're adding new policies for or interfaces access data at this layer. You'll have to recreate this logic in different places if you want to get consistent protection across all the different points in or layers in this cloud ecosystem architectures. And so again, the net here is it leaves a lot of layers open, because anything downstream or to the left of this isn't going to have the policy applies. You really have to lock that down, and maybe you have different users who aren't accessing data through these interfaces, and how do they, maybe they're using a notebook or something different, so they don't get to leverage that logic. All right, so finally, we'll look at, looking at time, we've got half hour in, so I'm gonna leave some time for questions, comments. But if we look at the final option here, it's really a decoupled policy enforced on the query and processing layer. So really we're looking at that layer, but looking at something that's maybe outside that box. So it's a decoupled layer from the architecture, which is what those icons represent. And what this means is the data engineering and operations teams, they can centralize the policy tiers across the layers of cloud data architecture. So for example, a single fine-grained access policy can get enforced consistently by integrating at the compute layer, thinking like Databricks, Snowflake, Athena, et cetera, rather than the storage layers to the left. And so this gives you from scoring perspectives, gives you the best safety because you're decoupling the policy enforcement at this layer where the compute's happening. And that enables you to centralize policy definitions and expectations through, we'll call it consistent abstraction, semantic layer, whatever you want to call it. And addresses that top challenge of masking and anonymizing data, since you're doing it once at this layer, and it applies across the entire architecture, to the right. And then monitoring and auditing was the second biggest challenge in the research. That this approach also provides the necessary oversight to answer very basic questions like who has access to use what data, when, and for what purpose. And I know most of the poli-sci teams know it's really hard to answer like a basic question like that in this cloud environment. And then from safety, and then looking at utility, using a central approach to this enforcing fine-grained access controls, it really enables you to implement more advanced policy techniques and do it in a consistent way. So you can unlock more of that data without that risk of leaks or manual errors when you make changes. And then scalability, centralizing this policy management provides that the best way to scale user adoption and ultimately data use, since the controls are really written once and applied across that across the right for the demand consumption side teams. And then again, without this centralized approach, if any of these layers are left open or can be bypassed, that's ultimately results in a data leak. And so your friends and the security compliance teams that are authorizing use, this is not a practice that they would approve in a lot of cases, and your use cases will get limited to what you can do. So the net here is really this approach to tame a lot of that complexity of managing sensitive data across so many layers of the cloud. And thinking about, well, how do you do that? There's some cloud native services that do some of this, like AWS Lake Formation. It decouples some of the policy enforcement for some of the AWS services, like I think like Redshift, Spectrum, EMR, or Athena is one example. And in looking at, I'm employed by Immuta, so we also provide, as another example, Immuta provides another commercial example that's agnostic to cloud. And most of the cloud access control services, on the left side of this chart, you have different attributes of what it takes to manage sensitive data access, like row level security, column level, being attribute based, et cetera. And then across are like examples of platforms. I didn't name specific ones, but thinking like Databricks, Snowflake, Redshift, BigQuery, or your analytical compute technologies. And you can see that heterogeneous environment on the left. And so it's really hard to write a policy once and run it across all of those without automation and these approaches in DevOps. And so, thinking about this and doing this centrally in a consistent way across these services, central platform teams, just from what I hear, they're often expected to be all-knowing and to fulfill a request for sensitive data from the business. You really need to know, like, not just the platform controls and how each one works, but you need to know the business context of data, how the requirements for each business line and their domain. And so the platform teams in the survey are really struggling as their resources are increasingly pulled away from engineering to manage these kinds of requests. And so teams are falling behind on SLAs. And again, this is where these DataOps approaches and automation are really needed to scale, as you saw, if you recall that image of all those, the teams on the left are being outnumbered by consumers. So this is the commercial example of that approach and the Immuta is one example. And what's the impact of this? At the end of the day, taking this decoupled policy enforcement approach to cloud, it really is, at the end of the day, it's increasing permitted use cases, increases the data engineering productivity. And we talked about those teams are a scarce resource in a lot of organizations. And then simplifying the roles to manage. When you see those like the 50,000 policies in this environments of sensitive data, and a lot of organizations are collecting, and I think we said virtually all of them are looking to use it. You end up with a lot of roles to manage, and simplifying that is really important to reduce the risk exposure. And then again, reducing time to data access is the ultimate end goal for data access and making the data usable by the consumers. And so these are some of the, I guess, impacts if you want to net out the big picture to the bottlenecks and like how addressing them can help. And so I wanted to save, I think we saved about 10 minutes for Q&A. So I'd love to hear questions, comments, if this is the research and the results or something you see, your reactions to some of the trade-offs. Stop sharing my screen and see if I can.
Okay. Thank you, Sumit. This is Chrissy Elect for your session, and we do have a few questions for you. If you're ready to address them.
Yeah, that'd be great.
Awesome. The first question came in from. No, I should. It's already muted. Oh, I'm just double checking that there's. Oh, I thought I muted it. Let me look at the ticket here. Sorry. No, I think it's muted. Wait. No, I'm not even joined. Yeah, no, that's fine. Okay, I was just double checking that I'm not echoing because I'm not connected on the feed loop platform through the audio. Okay, sorry about that, Sumit. The first question comes in through Mahesh from Selective Insurance, and he's asking, can you share the research that shows the ratio of data engineers to consumer?
Yeah, so we can share that research. It's still being developed. So if you can reach out to, I guess I should have some contact information somewhere in this event. But at the end of the day, we can talk in the conference. But we're working on a broader, more detailed survey to build on that. And so we should have that data available in about a month as a research white paper for you to consume. So if you can, and also happy to chat on the initial research done.
Oh, great. Thank you, Sumit. And Mahesh, hopefully that did address your question. If Sumit, I would imagine you're going to be available in the networking session. So Mahesh, if Sumit will be there. So Mahesh, if you want to pop into the networking, you could get Sumit's contact information to provide that update on the white paper. And the next question comes from Chris from San Jacinto College. He's asking, or it could be a she, sorry, Chris. They are asking, are you able to make available the full-scale version of the image for quote-unquote layers of data access controls across the cloud data ecosystems?
Yeah, definitely. That's a public image. It was from it was a different site. That was on A16Z. I'm happy to share the link if you want to reach out to me through the networking or through this event. I'm sorry, Chrissy. How is the best way to reach out directly?
To reach out. Let's see. With Chris didn't post. So Chris, if you're going to be available, the networking. Ping Sumit through there, or feel free to post your contact information in the chat, and I'll share it with Sumit. And yep. And so far, I'll monitor. I don't see the chat yet from Chris, but let's see. Not yet. They may be pulling up. To post their email. So, actually, I just see an update from Chris. They will be putting in either the contact information or perhaps find you during the networking session.
Okay.
And just double checking that there were any other questions that came through, and I don't see any additional questions, but perhaps people are shy. So those that might be shy for presenting the questions in the chat here, again, just swing on over to the networking, and Sumit, you'll be there to address any follow-up questions or further conversations.
All right, yep, definitely.